Welcome to the Deep Dive. Today, we're digging into something that, well, it's really shaken things up in the AI world. A bit of a plot twist, you could say.
Yeah, it really is, especially coming from OpenAI. For years, people have kind of joked about the open part of their name, given how closed most of their top models were.
Right, and then boom, they dropped this genuinely open weight model series. It really caught a lot of people off guard.
Totally unexpected for many, but
Yeah,
here we are.
absolutely. So we're talking about the new GPT OSS series.
Yeah.
There's the big one, the 120B model, and also this surprisingly powerful 20B version.
That's right. And we've spent a good amount of time wading through, the official announcements, the technical papers, which can be pretty dense.
Yeah, tell me about it.
To really pull it all together for you, our goal here is simple. Break down what these models are, just how powerful they actually are, peek under the hood of the tech, and crucially, talk about the safety side of things.
And figure out what it all means for, well, for you listening, for
Yeah.
developers, for businesses, for the future direction of AI. Let's unpack this.
Okay, so first things first, this idea of open weight. It sounds technical, but it's kind of the core of why this is such a big deal, isn't it?
Definitely. We hear open source all the time, but open weight is different. How exactly?
Okay, yeah, good place to start. Think of it like this. Open source usually means the code, right? The instructions, the sort of blueprint for a piece of software.
The skeleton?
The skeleton, exactly. But with these huge AI models, the real magic, the intelligence, the brain, if you like, isn't just the code, it's in the weights. These are the billions of parameters tuned during training.
Ah, okay. So the weights are the learned knowledge, the actual trained brain.
Precisely. So open weight means they're not just giving you the blueprint, they're handing over the fully trained, ready to go brain. You can download it, run it on your own machines, tweak it.
Build products on it even.
Yes, even build commercial products on it. It's totally different from just calling an API where the brain stays locked up on their servers. You're
Wow.
basically moving the intelligence in-house.
That's a massive shift.
Yeah.
Moving the brain, I like that. And they released this under the Apache 2.0 license specifically. Why is that choice significant?
Oh, it's hugely significant. Apache 2.0 is like one of the most permissive and business-friendly open source licenses out there. It basically says, take this, use it, modify it, distribute it, build commercial stuff, go nuts.
And you don't have that viral thing where if you modify it, your own code has to become open source too, like with GPL.
Exactly. None of that. You just need to keep the original copyright notice and license text.
Yeah.
Choosing Apache 2.0 is OpenAI basically saying, we want people to build on this seriously. It lowers the barriers massively and signals a real commitment to, a more open ecosystem.
Okay, that makes sense. So let's connect the dots for the listener. Why should you care about this? What are the tangible benefits?
Several big ones. First off, cost. If you're hitting OpenAI's APIs really hard, those paper token costs can add up, right?
Oh yeah, fast.
With open weights, you run it yourself, so your cost shifts to hardware and upkeep. For high-volume users, that could mean serious savings long-term.
Okay, potential cost savings.
Yeah.
What else? Control seems like a big one.
Huge. Complete control and privacy. Your data stays with you. It never leaves your servers to be processed by a third-party API. For industries like finance or healthcare, that's not just nice to have, it's often a requirement.
Absolutely critical. And what about making the AI, understand your specific world better?
That's the third point. Deep customization. You can take this base model and fine-tune it on your own stuff. Internal documents, specific industry knowledge, maybe a particular writing style for your company.
So it learns your jargon, your context.
Exactly. It starts to understand you better in a way a generic API just can't. That level of deep tailoring is really powerful.
And one more, thinking about edge computing or remote locations.
Offline operation. Yep. You don't need a constant internet connection. You can run powerful AI on devices out in the field, in secure facilities, wherever. That opens up a lot of possibilities.
Okay, those are compelling reasons. But it all hinges on whether these models are actually, good. OpenAI claims they're nearly as good as their paid models like O3, even O4 Mini. Is that real?
This is where it gets pretty eye-opening. The performance numbers are genuinely impressive. Take advanced math like the AM competition problems.
Yeah.
The 120B model didn't just compete, it beat O3 and O4 Mini, scored like 97.9% on the 2025 set. That shows some seriously strong reasoning ability now out in the open.
Wow, okay, beating their own paid models on math. That's a statement.
Yeah.
What about coding? Super important for developers.
Crucial. On Codeforces, which is like a coding competition simulator, the 120B with tools got an ELO score of 2622.
How does that stack up?
O4 Mini is a bit higher at 2719, but O3 is way down at 2066. So 2622. People are describing that as top-tier human programmer level, better than most actual human programmers.
That's kind of mind-blowing. A downloadable AI that codes at that level.
It really is. Think about having that capability in-house. Okay, general knowledge. MMLU benchmark.
The standard test, yeah.
120B gets 90.0%, very close to O304 Mini, which are around 93.0%. So really strong general understanding.
And specialized areas. You mentioned healthcare earlier.
Right, HealthBench. Assesses health-related conversations. 120B scored 57.6%, almost neck and neck with O3's 59.8%. And interestingly, it actually did better than older models like O1 and even GPT-4o on that specific benchmark.
That's really promising for potential applications, maybe in areas with limited access to expertise. But the safety caveat here is essential, isn't it?
Absolutely critical. OpenAI is crystal clear on this. These models are not for medical diagnosis or treatment. They do not replace doctors. Think of them as tools, maybe assistants, but never the final decision maker in healthcare.
Got it. Loud and clear. What about using tools like function calling for agents?
Pretty good there, too. On Taubench Retail, which tests that, 120B scored 67.8%, just behind O3's 70.4%. So it knows how to use external tools effectively.
And languages other than English?
It's mainly English trained, but on MMLU Multilingual, it averages 81.3% across 14 languages. Does quite well in major ones like Chinese, hitting about 80.9%. So respectable multi-language ability, too.
Okay, that's a seriously impressive report card. Now, the efficiency part. You said the 120B needs a hefty GPU and H100, but the 20B, that's the one that really raised eyebrows, right? Running on 16 GB of memory?
That's the stunner, yeah. 16 GB. That's like a decent gaming laptop spec. Imagine running something close to O3 Mini performance on your own machine. That's huge for accessibility.
How on earth do they do that? Squeeze so much power into such a small, well, relatively small memory footprint?
Two main tricks under the hood. First is mixture of experts, or MOE.
The committee of experts thing.
Exactly. Instead of one giant model doing everything, you have lots of smaller expert models. The 120B has 128 experts, the 20B has 32. But crucially, for any given task, a gating network only activates a few of them, like 4 out of 128 for the big one.
So most of the model is idle at any one time.
Right. It dramatically cuts down the computation needed per step while still having access to that huge pool of knowledge spread across all the experts. It's clever.
Very clever.
Yeah.
What's the second trick? You mentioned quantization.
Yep, MXFT4 quantization. This is about reducing the precision of the numbers, the weights in the model. Think of it like using fewer decimal places. They shrink them down from the standard 16-bit format used in training to roughly 4-bit.
And that makes the model file smaller.
Much smaller. The 120B goes from hundreds of gigabytes down to about 60.8 GB. The 20B shrinks to just 12.8 GB. That's how you get it to fit into 16 GB of RAM. It's absolutely key for running on consumer-level hardware.
Okay, MOE and quantization. Got it. Any other optimizations worth mentioning?
They use things like grouped query attention, GQA, and rotary positional embeddings, ROPE Part E. These help manage memory and computation, especially when dealing with really long inputs.
Speaking of long inputs, context length.
Pretty impressive. A native 128,000 tokens.
Wow. That's a lot of text. You could feed it a whole book.
Or very long documents, complex code bases, extended conversations. Really useful for tasks needing a deep understanding of a large amount of context.
And one more feature that sounded really interesting. Variable effort reasoning. What's that about?
Yeah, this is cool. It gives developers control over how much thinking the model does. You can set the chain of thought, or CAUT effort, to low, medium, or high in the prompt.
So you can tell it to think harder or think faster.
Basically, yes. Higher effort means a more detailed, step-by-step reasoning process. The CAUT is longer. That usually leads to more accurate answers for complex stuff, but it takes more time and compute power.
And lower effort.
Faster response, simpler reasoning. Good for quick tasks. The neat part is you get to choose that trade-off between accuracy, speed, and cost for your specific application. It's about giving developers that fine-grained control.
That's really smart, tailoring the thinking process itself. Okay, let's shift to how these models were actually trained and the special language they used, the Harmony format.
Right, so the training data was massive trillions of tokens, big focus on STEM, coding, general knowledge, mostly English, and the knowledge cutoff is June 2024, so pretty up to date.
And safety was considered during training.
Yes, they filtered the pre-training data for harmful content, especially CBRN risks. That's chemical, biological, radiological, nuclear stuff, using techniques they developed for GPT-4o. So safety was built in from the start.
Okay. And after pre-training, how did they align it? I heard the term COTRL.
Yeah, QOTRL, chain of thought reinforcement learning. It's similar to how they trained O4 Mini. It essentially teaches the model two main things.
Okay, what are they?
First, chain of thought itself, getting the model to think step by step before giving an answer. This really helps with complex problems, like some math problems needed over 20,000 tokens of internal thought, and it makes the reasoning more transparent. You can see how it got the answer.
Right, showing its work. And the second thing?
Tool use. Teaching it when and how to call external tools, calculators, code interpreters, maybe web search to go beyond what it inherently knows. Crucial for real-world usefulness.
Okay, so it learns to think and use tools. Now, this Harmony chat format sounds complicated. Why not just user assistant messages?
It is more complex, but it's designed for flexibility and safety. It uses special tokens, defines specific authors like system, developer, user, assistant, tool, even recipient for when multiple agents might interact.
Whoa, okay, so it's really built for sophisticated setups. I heard there's a hierarchy too.
Yes, a strict priority. System instructions override developer instructions, which override user input, and so on. This is a key safety feature. It helps ensure the model follows core safety rules, even if a user tries to steer it otherwise.
Makes sense. And the really innovative part seemed to be these channels.
Ah, yes, the channels. This is quite clever. The model separates its output. There's an analysis channel for its internal step-by-step thinking, the COTI. There's a commentary channel for things like tool calls and results. And then there's a final channel with just the clean, concise answer meant for the end user.
So as a developer, I can access all the messy behind-the-scenes thinking for debugging or advanced logic.
Exactly.
But I only show the neat final answer to my user.
Precisely. You get the best of both worlds. Transparency and control for the developer, clarity for the user. It's really geared towards building complex, agent-like systems.
Okay, this structure naturally leads us into the safety discussion, which is obviously huge with open weights. How did OpenAI approach this?
It's a multi-layered approach. We mentioned the pre-training data filtering. Then, post-training, they use techniques like deliberative alignment to teach the model to refuse harmful requests and resist jailbreaks. Plus, that instruction hierarchy we just talked about is another safety layer.
Right. But then there's that decision about the chain of thought, the analysis channel. They didn't specifically train it to be safe, right? That sounds risky. Why?
It's definitely the most controversial part, and they acknowledge the trade-off. Their reasoning is based on research suggesting that if you force a model to hide potential problematic intermediate thoughts, to basically lie about its reasoning process, it becomes much harder to detect when it might actually be developing harmful capabilities or intentions.
So leaving the internal thoughts raw, even if sometimes problematic, is actually more transparent. You can see what it's really thinking.
That's the idea. Transparency over forced, potentially deceptive, safe-washing of the thought process. But, and this is a huge underlining, but it means that raw QT in the analysis channel can contain errors, biases, or even steps that violate safety rules if taken out of context.
Which means
OpenAI emphatically warns, do not show the raw QT directly to end users, ever. The developer must process, filter, or summarize it appropriately before presenting anything based on it. The responsibility shifts heavily onto the person implementing the model.
wow, okay. That's a major responsibility.
Yeah.
How do they test for worst-case scenarios, like someone deliberately trying to make these models harmful?
They did what's called adversarial fine-tuning. They essentially role-played being a sophisticated attacker, using advanced techniques to try and push the 120B model towards generating harmful content, focusing specifically on those high-risk CBRN areas and cybersecurity.
Like a simulated black hat hacker training the AI for evil.
Pretty much, yeah, using their best methods to try and break its safety training.
And the result? Did it become significantly more dangerous?
According to OpenAI's report, no. Even after this intense adversarial fine-tuning, the model didn't reach their predefined threshold for high capability risk in those sensitive areas.
Right.
And crucially, when they compared its potential for harm after this malicious tuning to other powerful open models already out there, models like DeepSeek, KIM-K2, the fine-tuned GPT-OSS model, didn't represent a significant new level of risk. It wasn't pushing the boundary of danger beyond what's already accessible.
So their argument is, It's powerful, but not uniquely dangerous compared to the existing open landscape.
That seems to be the core argument, yes. That the marginal risk added by releasing this specific model, given what's already available, is manageable with the safeguards and warnings they've put in place.
And they didn't just rely on internal tests, right? They involved external reviewers.
Correct. They had independent safety experts from places like Metro, Secure Bio, and researchers like Daniel Kahn review their work. These experts made 22 recommendations, and OpenAI says they adopted 11 of them before release.
And that big red teaming challenge.
Yeah, the $500,000 prize pool. That's basically inviting the entire global community to poke holes in it, find vulnerabilities, find misuse cases. It's a very public way of stress testing the safety and building confidence.
So, summing up the safety picture.
It's complex. The models aren't perfect out of the box. They note some issues like weaker instruction following or more hallucination compared to, say, O4 Mini, which developers need to handle. But OpenAI seems confident that the overall risk profile, given the context of existing open models, is acceptable for a controlled release. But again, the onus is really on responsible deployment by the users.
A cautious leap forward, then. Okay, let's talk practicalities. For people listening who are excited to try this, how do they actually get it and run it?
Access is surprisingly straightforward. The models, including those quantized MX FP4 weights we talked about, are up on Hugging Face, freely available.
Hugging Face, okay. The main hub for models
Yeah.
and running them.
Lots of options depending on your technical comfort. If you're a Python developer, Hugging Face's own Transformers library supports them. If you want to quickly spin up an API endpoint, VLLM is a popular choice.
What about less technical users? Just want to run it on their desktop.
Yeah, tools like Llama and LM Studio make it pretty easy to download and run models locally, even on consumer hardware, assuming you meet the memory requirements for the 20B model especially. And Microsoft even put out a version optimized for Windows GPUs.
So a good range of tools. Did OpenAI build this ecosystem support alone?
No, they were smart about it. They partnered widely before launching. Cloud providers like Azure and AWS are offering them. Inference platforms like Fireworks AI and Together AI have them ready to go. Hardware folks, NVIDIA, AMD, Cerebras, Grok, they worked with them too to ensure things run efficiently.
So they really laid the groundwork for broad adoption.
Definitely. They wanted to make sure it wasn't just available, but actually usable across many different systems and platforms right from day one.
And customization. Fine-tuning was a big selling point. How feasible is that?
Both models support it. The 120B needs serious hardware like an 8-GPU H100 node, so that's more for well-resourced organizations. But the 20B model, OpenAI says it can be fine-tuned on some high-end consumer GPUs.
Ah, okay. So individuals or smaller teams could realistically fine-tune the 20B model themselves.
It seems so, yeah. That really opens up the potential for deep customization, even without access to, massive compute clusters. It's a big enabler.
Okay, stepping back for the bigger picture. Why now? Why did OpenAI, the company often seen as leading the proprietary AI charge, make this big move into open weights?
Well, their official line is it's part of exploring how they can contribute to a healthy open model ecosystem. They talk about lowering barriers, fostering innovation, AI democratization.
Helping maybe in places where expensive APIs aren't viable.
Exactly. Emerging markets, research labs with tight budgets, specific industries, and let's be honest, it's also a pretty direct answer to years of criticism about the open in their name not matching their actions.
Addresses that critique head on, yeah. So this creates a real choice for developers and businesses now, doesn't it? GPT-OSS versus the OpenAI API like GPT-4o. How do you decide?
It really comes down to your specific needs and priorities. You'd lean towards GPT-OSS if complete control and data privacy are non-negotiable. Like we said, finance, healthcare.
Right. Or if cost at very high volume is the main driver.
Yeah, if you're making millions of calls, running it yourself might be cheaper than the API fees, even with hardware costs. Also, if you need that deep private customization through fine-tuning on your own data.
And the offline use case.
And offline or edge deployment, definitely. Plus, if you need that peak performance in specific areas where GPT-OSS currently shines, like that advanced math or coding capability.
Okay. And when would you stick with the tried and true OpenAI API like GPT-4o?
You'd stick at the API if you need the absolute state-of-the-art general-purpose model, especially for multimodal tasks involving images or audio, where GPT-4o is still generally considered top dog.
Or if convenience is key.
Absolutely. If you just want the easiest integration, the It Just Works experience without managing infrastructure, the API is simpler. Also, if you rely heavily on the built-in tools like web browsing or the code interpreter that are tightly integrated into their API products.
And updates.
And if you want OpenAI to handle all the continuous updates, improvements, and maintenance behind the scenes, with Open Weights, you manage the model version. So yeah, it's a trade-off. Performance, costs, latency, control, convenience, you weigh those factors for your project.
What an incredibly detailed breakdown. We've really gone from the initial surprise of this open-weight release, through the nuts and bolts of performance and architecture, all the way to the tricky safety aspects and practical choices.
It's definitely a landmark release. OpenAI putting models this powerful out there under such a permissive license, it's a big moment. It gives so much capability and flexibility directly to the community.
It feels like it's bound to accelerate things,
Yeah.
innovation, new applications, maybe wider access globally. But like we discussed, it's not without its complexities, particularly around safety.
For sure. They've clearly put a lot of thought into the safety measures, the testing, the transparency efforts, like not hiding the raw KT. But
Right.
as we keep saying, it does shift a significant amount of responsibility onto those who choose to download and deploy these models.
And that really leads perfectly into a final thought for everyone listening to mull over. This GPT OSS release, it truly feels like a new chapter in making powerful AI more accessible. Democratization, as they say.
Mm-hmm.
But here's the really fascinating question it raises, especially with that decision to leave the raw chain of thought transparent but unsupervised. It puts the spotlight firmly on us, the users, the developers, the implementers.
Are we actually ready for that level of responsibility? Do we have the right tools, the right understanding, the right ethical guidelines to properly look inside these AI brains, to scrutinize their raw thinking and not just blindly trust the final output?
It's more than just using a tool. It's potentially about guiding and understanding a thought process. This shift, it could change more than just the speed of innovation. It might fundamentally alter how we interact with, how we understand, and ultimately how we govern these increasingly powerful intelligences we're creating.
Yeah. It's a deep question. No easy answers there, but it's definitely something we'll all be grappling with as AI like this becomes more and more integrated into our world.